Today's lesson continues on with the idea of trig when you've escaped the 90-degree limitation of acute angles. We're going to talk about trigonometric ratios for angles between 0 and 360. So the pattern I was hoping you would pick up from doing the work last time is this quadrant here, or this pattern here. The sine is positive in quadrant 1. Sorry, I don't know why this is underlined. Get rid of that. Positive in quadrant 1, positive in quadrant 2, negative in quadrant 3, negative in quadrant 4. This means if you pick an angle between 0 and 90 and do its sine, you'll get a positive. If you pick an angle between 90 and 180, you're going to get a positive. But if you pick an angle between 180 to 270, right, which is quadrant 3, right, just down here, you will find that sine gives you a negative answer. Similarly, if you pick a sine in this bottom quadrant, you'll get a negative answer. For today's assignment, there's a utility that'll kind of help you visualize this. If you look here for a sec. So this applet, it talks about trigonometric angles, ratios of angles between 0 and 360. So right now, I have an angle of 0 degrees, right? And that's why my initial arm over here and the terminal arm are right on top of each other, and you can't even really see an angle. If I make the angle like 40, let's say. Okay, so again, notice theta is the principal angle. It is the angle that is made between the initial arm in black and the terminal arm in blue. Beta is the angle that your line makes with the x-axis. Now, of course, in quadrant 1, they're the same. So it's hard to demonstrate them in quadrant 1. But if you look here, you'll see that sine beta is 0.6428 and sine theta is also 0.6428. They're the same in quadrant 1. Now in quadrant 2, okay, look here. So in quadrant 2, theta is 130, but beta is only 50 because beta is, the angle that it makes with the x-axis, not with the initial arm. Now, what we notice here is that sine beta and sine theta are actually still the same. Because in quadrant 2, sine stays positive. What we notice about cos and tan, though, is that the numbers stay the same, right? 1.1918, but tan and cos become negative in quadrant 2. And again, the reason we'll get into the reasoning of why a little bit later, but just to remember. So we call this quadrant the A quadrant because all ratios are positive. When you keep moving into quadrant 3, okay, now sine has become negative, cos is negative, and tan remains the same. Tan stays positive, right? Finally, when we go into quadrant 4, sine becomes negative, tan becomes negative, but cos stays positive. So this information, rather than like memorize all of that, is a fairly simple way to remember it. So let's just write it down here. So cos is plus, minus, minus, plus, and tan is plus, minus, plus, minus, right? So that's the pattern. This can be sort of an easy way to remember this table is to remember this thing called cast. So you start with a C in the bottom right corner. I think there's a picture of it. Well, actually, no, there isn't, but okay, so the C goes in the bottom right corner, the A goes in the top right corner, the S goes in the top left corner, and the T goes in the bottom left corner. And that will remind you what is positive in that quadrant. So in quadrant 1, all are positive, sine, cos, and tan. In quadrant 2, which is the S quadrant, only sine is positive. In quadrant 3, which is T, only tangent is positive. And in quadrant 4, only cosine is positive. So that's just a quick way to remember which one is positive or negative where. So this one, it says, for each of the following ratios, use a sketch to determine in which quadrant the terminal arm of the principal angle lies, the value of the related acute angle, and the sign of the ratio. Okay. Now, for this one, sine 110. I think what I'm going to do here is I'm going to just I'll use GeoGebra to draw it because I think drawing it in Word is a little painful. But let's just do it this way, okay? So this is going to be in quadrant 2. And I know that because 90 is less than the 110 in the question, is less than 180. So it fits in quadrant 2, right? Just remember quickly, quadrant 1 is 0 to 90. Quadrant 2 is 90 to 180. Quadrant 3 is 180 to 270. And quadrant 4 is 270 to 360. Okay? So that would be everything, just to remind you where they all are. So like for this one, for example, we know right away this is in quadrant 3 because 180 is less than 255, but that's less than 270, right? So I can identify this angle is going to belong to quadrant 3. This one, on the other hand, will belong to quadrant 4 because it's bigger than 270, but it's less than 360, so it's in quadrant 4. Okay? So just that will remind us. Now in quadrant 2, sine is positive. So I'm expecting it to be positive. In quadrant 3, cosine is negative. Cosine, remember, is positive in quadrants 1 and 4. Tangent is negative in quadrant 4, right? Because it's only positive in 1 and 3. Now it says, find the related acute angle. Now, I would suggest drawing it for the related acute angle until you get the hang of this. So let's just use this to draw them for a sec. So let's draw, it asks for an angle of 110, right? So here's 110. Let's just take a quick screenshot of this. So your picture, of course, is not going to look exactly like this, but it should look, pretty similar. You have a terminal arm, an initial arm on the right. You measure 110 degrees, which you know would be past 90, but not too much past 90. And then the beta, right, which is in orange in my picture, the beta is how much to get to the nearest x-axis, right? So I'm going to write here theta equals 110, beta is equal to 70, right? Because it would take 70 degrees to get from 110 to the nearest x-axis from 110. Okay? Now if you compare sine of 110 and sine of 70, okay, you should expect that the two values are the same. And not only will the two values be the same, but they will both be positive because we're in a quadrant where sine is positive. Okay, so I'm going to write sine 110 equals sine 70. And so they're equal to each other, and they're both equal to 0.9397. Okay, and that's everything from this question. Let's try the next one. So it says cos of 255. I already know it's a negative because of where it is, but let's draw 255 and you can see. Okay, so here is 245, 255. Okay, very good. Okay, so let's draw. Collect this. Copy. Paste. Okay, what do we see in this picture? Okay, again, theta, which is the principal angle. Theta is 255. Okay, beta, therefore, is how do you get to the nearest x-axis? Well, the x-axis was back at 180. So how did I get from 180 to 255? I added 75 degrees, right? And where is this coming from? It's because 180 plus 75 equals 255, right? So now, cosine of 255 is going to be the same thing as cos 75 because they're the same related angle, except it's going to be negative because I'm in a quadrant where cos is negative. So notice when I check, cos beta is 0.2588 and cos theta is negative 0.2588. So cos 255 is equal to 0.2588. Okay? Last question, we're supposed to draw a 305 degree angle. So let's do so. 305 is over here. Okay, and let's just shrink it down so it fits better. What do we see in this picture? Theta is 305. That's what we were asked to draw. Beta would be, how do you get to the closest x-axis? The closest x-axis here is 360. So we do 360, take away 305, and we get 55 degrees. And again, I'll just write in brackets how I got that is 360 minus 305 equals 55, because 360 is the closest x-axis here. Okay, so with that in mind, okay, I know that the tan of 305 is going to be equal to the opposite of tan 55. Okay, because they have the same reference angle, they make the same angle with the x-axis, but you're in quadrant 4, tangent's negative in quadrant 4, so we take the one from quadrant 1 and just make it negative. And that's why you get tan 305 is equal to 1.4281. And that is the answer there. Okay? Now it says, use the related acute angle to state an equivalent expression. Really important task, right? It's something that if you continue on in functions, it gives a lot of people trouble in grade 12, but it isn't super difficult if you can just remember where all these things come from. Let's not use the circle this time and state an equivalent expression. So sine 120, right? Let's just write out all the steps. Theta equals 120 degrees. Okay? The closest x-axis can either be 0, 180, or 360. Obviously, in our case, the closest x-axis is 180. And therefore, the beta in the question, which is the related acute angle, is how far away are you from the closest x-axis? The answer would be 60 degrees, right? And in the bracket here, I'm just going to write, let's just write where we came up with this. Theta equals 180 minus beta. That's what the relationship is here, right? You're in quadrant 2, and theta and beta are related according to this equation. Okay? Now finally, what does this, why would I do this? Because I know that sine, now here's where you get to the related expression part. Okay? So just again, try and pay attention and just, what does this mean? I know that sine theta is related to sine beta. They always have the same numbers. Like, just look here, right? No matter how I change it, sine beta and sine theta have the same numbers every time. The only thing that can be different is whether they are positive or negative. Is it positive or negative? So think of it this way. Sine beta, because beta is an acute angle, so sine beta is always positive. Sine theta, on the other hand, sine theta is positive in Q1 or Q2. So where am I in this question? In this question, I'm in Q2. Therefore, right, sine theta and sine beta are the same. Now listen, every single answer is either going to be this, or it's going to be the same thing with a negative in front. It cannot be anything else. So all you really have to do here is find beta and then decide, is my theta in a quadrant that's positive or negative? If it's positive, leave it alone. Just say sine theta equals sine beta. If it's negative, say sine theta equals negative sine beta. We'll do this for this one a little bit quicker. Okay? So again, same idea. Let's start with theta is equal to 230 degrees. The closest x-axis would be 180 again. And therefore, beta is how far away we are from 180, which you should be able to see is 50 degrees. We'll just write in brackets, what could I say here? In quadrant 3, right, you have this relationship. Sorry, I need to be an equation. In quadrant 3, you have this relationship, okay? Theta equals 180 plus beta. No, not gamma, beta. This is the Q3 relationship, whereas this was the Q2 relationship, right? Because when you're in quadrant 2, you can't be bigger than 180. In quadrant 3, you have to be bigger than 180. So that's why I'm writing it that way. Now, what does this mean? This means cos of 230, okay, has to be the same number as cos of 50. Okay? And I guess what we could say here is, we could say absolute value, but I think that would be confusing. I'm just going to leave it alone. Now, ask yourself, in quadrant 3, cos is negative, right? So I'm going to get rid of this equals. I think this is confusing. Okay? Now, in quadrant 3, cos is negative. So what do? I say cos 230 is the same number as cos 50, just negative. So you see how the answer is the same? So here, my answer was, just to finish this one, sine of 120 equals sine 60. So sine theta equals sine beta. Here, let me just type it this way. I'm going to just copy paste probably faster. Okay, cos theta is equal to cos beta, but it has to be negative because you are in a quadrant where cos is negative. Since cos beta is always positive, beta is an acute angle, cos theta has to be, you may need a negative sign to make them equal. Now in this one, right? So again, let's just copy what we have, so we use the same format. Theta is 350. Obviously, the closest x-axis is 360, and how did we get that? Theta equals 360, take away beta, and that's the formula in quadrant 4. Okay? Now, this tells me that tan of 350, okay, is related to tan of 10. Okay, I just don't know how they're related. So in quadrant 4, tan is negative. Therefore, tan of 350 is equal to negative tan of 10. And again, the formula would be the same as this. Tan theta, I was supposed to save time, not delete the angle. Tan theta is equal to negative tan beta in quadrant 4. So this work is not difficult to do, but it is a little bit difficult to understand. So, go through a few practice questions or just make some up and see if you're